Hey pre-calc students, welcome to Lesson 2.1 Notes, Part 3. Today we're going to review some important vocabulary that has to do with quadratics, including solution, zeros, and x-intercepts. I'm also going to review how to solve quadratics both in standard form and vertex form. So first things first, when you graph a quadratic function, there are three things that could happen. You can have a parabola that intersects the x-axis once. So it's possible that you have a parabola, whether it opens up or down. Okay, so I'm just going to draw the same one on both sides because I'm going to explain to you the difference between the three vocabulary words at the top of your paper. Solutions, zeros, and x-intercepts. So if you were asked for a solution or a zero, you would write your answer as x equals -5. But if you were asked for the x-intercept, think of PT stands for point, then you would write it as -5, 0. Now parabolas can intersect the x-axis twice. So let's say we had one that intersected twice. This is just an example. Then you would write both solutions or zeros as x equals -2 and x equals 0, no matter where it intersects the x-axis. So again, it is possible for a parabola to have one solution, two solutions, these are called real solutions, or what could happen is you might have a parabola that will never intersect the x-axis. Then in that case, you say no real solution. It's not good enough to say no solution. You have to say no real solution because it actually does have an answer, but it's imaginary. And imaginary numbers cannot be graphed on a regular coordinate plane. So again, if your parabola or your quadratic does not touch the x-axis, then it has no real solution. In this case, if they were asking you for the intercepts, oh my goodness, I just realized I messed up. We got to write these as ordered pairs. So the x-intercepts would be -2, 0, and 0, 0. So remember, intercepts are points. Whew, good catch. Okay, now, and this parabola looks like a hot mess. If your parabola does not, oh Lord of Jesus. Okay, if your parabola does not touch the x-axis, then you say that it has no x-intercept. So essentially, whether they ask you for a solution or zero, or if they ask you for an x-intercept, you're trying to figure out where your function intersects the x-axis. So that's what they have in common. The difference is how you write the answer. So that's how I knew I did something wrong on the x-intercept, because I had written it with an equal sign and it should have been an ordered pair, a point. Okay, so that's just a basic vocab review. Now we're going to start solving quadratics in standard form. You can solve quadratics in standard form by using the quadratic formula or factoring, but it depends. Now, first things first, whenever I give you a function and I ask you to solve it and it's in standard form, you're going to start by setting it equal to 0. After that, I want you to use the discriminant to help you decide how many how many answers, what kind of answers you're going to get, and what method and strategy is best for solving. So here's what I recommend. Now, b squared minus 4ac is the part that's under the square root in the quadratic formula. So it discriminates between the most efficient method and the types of solutions that your quadratic has. There's three things that could happen. Your discriminant could be negative. That would mean that your parabola has no real solution. So that means no x-intercepts. And that means you don't have to do any other work besides that for solving. If it's a perfect square, such as 4, because the square root of 4 is 2, 9, square root of 9 is 3, 49, square root of 49 is 7, okay? That means that it could have up to 2 real solutions. So it could have 1 real solution or 2 real solutions, and the best strategy for solving it is to factor. You can also use quadratic formula. But I tend to realize, or for me, I feel like factoring is faster. But you could also use quadratic formula. If it's not a perfect square, so if you find the discriminant of a quadratic and it is not a perfect square, then you can't factor it and you could only use the quadratic formula. But that quadratic can have 1 or 2 real solutions. Okay, let's take a look at example 1. Find the zeros of f of x equals 5x squared minus 3x plus 2. First things first, this is standard form. I'm going to go ahead and find the discriminant to help me decide what method is best for solving. So b squared minus 4ac. Pause the video, find the answer. By the way, calculator is okay for these. You should have gotten negative 31. What does that mean? Well, we just mentioned previously that if the discriminant equals a negative, then there is no real solution. That means that there are no real zeros. So to answer the question, no real zeros. Because remember, zeros and solutions are essentially the same thing. So no real solution means no real zeros. There could be imaginary zeros, but in this one, okay, so this one in particular could have imaginary zeros, but it doesn't have any real zeros. All right, pause for a second. So pause the video and find the value of the discriminant of example 2. Okay, pause the video, no cheating. Pause the video, find the value of the discriminant, and push play when you're ready to check your answer. I get an answer of 144. That is a perfect square, so that means that to solve this, I need to use factoring or the quadratic formula. I like using factoring when possible. So the first thing that I'm going to do, now remember the discriminant isn't the solution, isn't the answer. It's a method of telling you what strategy is best for solving. So because the discriminant is a perfect square, you can use quadratic formula or factoring to solve it. So you're going to start by replacing g of x with 0. Then I'm going to factor. Remember, everyone has their own method of factoring. Here I'm looking for two numbers that multiply to negative 35, but add to negative 2. This is called splitting the middle term, or factor by grouping. So the two numbers that would work are 5 and negative 7. Some of you guys use the little x, right? Miss Wilson taught you, I think, the x and slide, divide. I don't know. Miss Wojcik uses the box method. Okay, so I am going to go ahead and split the middle term into a positive 5x and a negative 7x, because if I wanted to, I can combine those terms, and I'd end up with the same thing that I started with. Now I'm going to go ahead and factor the GCF of the first two terms. So the GCF of the first two terms is 5x. I'm going to find the GCF of the second two terms, which is negative 7. And then I'm going to use backwards distribution to figure out 5x times what will give me 5x squared. 5x times x. 5x times what term will give me 5x? 5x times 1. Now everyone factors differently, remember? But our goal here is to solve, find the solution. So I'm going to, once I factor it and I have my two binomials, I'm going to go ahead and set each binomial equal to 0. This is called using the zero product property. So either one of these is a solution. So I need to solve for both. So add 7 to both sides, divide by 5. So one of my solutions is 7/5. Remember, solutions, you need to write them with an equal sign. And then subtract 1 from both sides, and you get x equals -1. So this quadratic has two real solutions. Remember that quadratics can have two real solutions, one real solution, or no real solutions. Okay, find the x-intercepts of h of x equals 1x squared minus 2x minus 5. I'm going to go ahead and use the discriminant to help me decide what strategy is best for solving this. So go ahead and pause the video and find the value of the discriminant. Push play when you are ready to check your answer. Okay, I got an answer of 24. That is not perfect. So whenever your answer for the discriminant is not perfect, then I recommend that you use the quadratic formula. Now, in case you forgot, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So notice that the 2a is under the entire numerator of opposite of b plus or minus the square root. A lot of people think that the 2a is only under the square root, but it's under everything. Okay, so if I substitute my values of opposite of b plus or minus the square root, now remember, this is the discriminant. B squared minus 4ac is the discriminant. That's the part of the quadratic formula that's under the root. So I've done that already. That's one benefit of using the quadratic formula in these problems. All over 2 times a, which is 2. All right, so you need to be able to give me exact and rounded answers. So I'm going to go ahead and break down the root first for my exact answer. So my exact answer can't have any decimals. Square root of 24 breaks down into square root of 4 times 6. Remember, you're trying to find the biggest perfect square that goes into it. So I'm going to have 2 plus or minus 2 root 6, all divided by 2. You need to make sure you reduce each part by 2, because it's a binomial, so both pieces need to be reduced by 2. So that's 1 plus or minus root 6. Or you can put the 1 there if you want, 1 root 6. That is the exact answer. So as intercepts, you would say it's 1 plus root 6, comma 0, and 1 minus root 6, comma 0. That's the exact answer. If they wanted the approximate answer, then you would need to put 1 plus root 6 in your calculator. So go ahead and do that now. Do 1 plus root 6 and then 1 minus root 6. Now, for approximate answers, I want you to round to the hundredths. Which is the second decimal. Okay, check your work. You should have 3.45 and -1.45. Practice using your calculator. So again, when you have something written in standard form and you're asked to find the zeros, solutions, or x-intercepts, I recommend that you use the discriminant to decide what strategy is best, whether it's factoring, quadratic formula, or whether it's no real solution and you don't have to do any steps at all. Okay, for example 4, the equation's already set equal to 0, so that's something less that you have to do. And they want you to find the where this parabola intersects the x-axis. So the way that you solve vertex form equations is to use inverse order of operations. I call that SADMAP, which is please excuse my Aunt Sally, but backwards. So you're going to cancel any addition or subtraction first, any multiplication or division, then exponents, then anything in parentheses. So if you take a look at your equation, the first thing that you want to do is you want to cancel addition and subtraction. Your goal is to ultimately leave the variable by itself. So you're slowly trying to get rid of all the numbers that are either added, subtracted, multiplied, etc. with that variable. So that takes care of subtraction and addition. There is a number multiplied on the same side where the variable is, and that's a 3. So I'm going to go ahead and divide it to both sides. 3 divided by 3 is 1. And 1 times 7x squared is just x minus 7 quantity squared. 48 divided by 3 is 16. This is the point where you are now canceling exponents, so I'm going to square root both sides, but remember we've discussed this, that when you square root both sides while you're solving, you need to consider the fact that there are two solutions. Now the square root of 16 is perfect, but it's not just 4, it's plus or minus 4, positive and negative 4. Then all you have left is canceling the number inside the parentheses, but again, you have two answers here. You have a positive 4 and a negative 4 that need to be written with a plus 7. And to fulfill the requirement of how to write the answer, they asked for the intercepts, so you would write 11, 0 and 3, 0. Remember, whether they ask you for x-intercepts, solutions, or zeros, the steps are essentially the same. If the function is not set equal to 0, you're going to have to do that first. So in this example, I have to set it equal to 0. Now they're asking me for the solutions. So remember, solutions are not written as ordered pairs. You write them just as zeros. So x equals, or solutions, right? X equals. Okay, I'm going to go ahead and follow SADMAP. Remember, it's cancel any addition or subtraction that is outside of the parentheses. Then any multiplication or division. I'm going to go ahead and use the reciprocal. Remember, we're using SADMAP. So in these few steps, we canceled subtraction with addition. Here we canceled multiplication and division. Now we're on the E, canceling exponents. Remember, when you square root both sides, you're going to have a plus or minus. And then your last step is to get rid of the number in the parentheses. But here's the thing. Square root of 8 is not perfect. Square root of 16 in example 4 was. Square root of 8 needs to be broken down. Break it down into square root of 4 times square root of 2, which is 2 root 2. Now when I subtract the 3 is not a like term with 2 root 2. So in order for you to be able to add or subtract radicals or roots with other numbers, is they have to have the same root or radical. So since negative 3 does not have a root, then it needs to stay separate. So usually you put the regular number and then the radical afterwards. So the exact answer would be -3 plus 2 root 2. So again, they cannot be added because the 3 doesn't have the same root as the other one. You could, however, add 3 root 2 plus 2 root 2. Then you would be able to, or -3 root 2 plus 2 root 2. Those you would be able to add because they have the same root. So for exact answers, you would have x equals -3 plus or minus 2 root 2. You could break it up and give me two separate ones, but I tend to do that only if they ask for approximate. So for approximate, I need to find the value of -3 plus 2 root 2, and I'm going to round it, so I use a squiggly equal sign, and -3 minus 2 root 2. So pause the video and go ahead and practice putting those in your calculator, and let's see if you get it right. All right, guys, so remember, when it comes to solutions and zeros, you want to write your answer as x equals, and then whatever answers you got. All right, continuing on with the idea of solving by using SADMAP. I'm going to cancel any addition or subtraction outside of the root first. Then I'm going to go ahead and multiply both sides by the reciprocal to get rid of the multiplication that the 4/5 was doing with the x plus 1 squared. So those cancel to 1. -36 times 5/4 is -45. So the next step would be to square root both sides, but you're going to get an error when you square root -45. Now, if you want to, you could break it up into an imaginary number of 9 times 5, square root of 9 times square root of 5. But for the sake of the question that they asked us find the zeros, we're talking about real zeros, you would say here that there are no real zeros. You can give me the imaginary zeros, which would be plus or minus 3i root 5, but I'm okay with you just saying no real zeros. All right, guys, as always, if you have any questions, please make sure you reach out to me on Remind. Have a great day.